So today's problem comes from the MIT 2024 Integration B regular season, problem number 11, which is the definite integral from x equals to 0 to 1 of e to the power negative x times the square root of 1 plus cotangent squared of arc cosine of e to the power negative x. So it's an interesting problem. Thank you so much for all the support. For those of you who have subscribed to our channel, we do really encourage. Those who haven't subscribed, do really subscribe to our channel because that support really will go a long way in giving us the support that we do need. So with this problem, first thing I would do is substitute for e to the power negative x and just letting u be equal to e to the power negative x means that du dx is equal to negative e to the power negative x, such that du equals to negative e to the power negative x dx. So we can substitute for the product of, let me indicate this, for the product of e to the power negative x and dx with the du negative. Also, the limits when x equals to 0, u is equal to e to the power 0. When x equals to 1, we have e to the power negative 1. So essentially, our integral here now, trying to reorganize a little bit, bunching this e to the power negative x and this dx together, and then trying to differentiate it a little bit by having a different color. So this part here can now be substituted with du negative, right? And then this can be substituted with 1, that is e to the power 0, and this with e to the power negative 1, and then this with u, right? So doing that means that now we do have a much tractable integral. We can now remove this sign here coming from this by flipping the limits. So the upper limit goes lower and then the upper limit, the lower limit goes up. And so now we do have the integral from u equals to e to the power negative 1 to u equals to 1 of the square root of 1 plus the cotangent squared of cosine of u. Now we can express this cotangent as the fraction of cosine squared arc cosine u over sine squared arc cosine u. And then making this sine squared as a common denominator inside the square root sign means that now in the numerator we have sine squared plus cosine squared, which is an identity that leads to that numerator being equal to 1. And then the denominator remains as sine squared arc cosine of u. Using the same identity, we can now express the sine squared component as 1 minus cosine squared arc cosine of u. And that means that we have now the integral of the square root of 1 over, because this here is the same as u squared, right? So cosine arc cosine u times cosine arc cosine of u, which is just u squared. And so the square root of 1 up there, we have 1 over square root of 1 minus u squared. So 1 comes out of the square of sine that way. We can now do another substitution by letting u be equal to sine theta. That means that du d theta is cosine theta, and therefore we can substitute for du with cosine theta d theta. Now the limits when u equals to e to the power negative 1, e to the power negative 1, theta becomes arc cosine e to the power negative 1, and when u equals to 1, arc cosine of 1 is pi over 2. So we have substituted appropriately. Where we have u, we have sine theta. Where we have these limits, we have appropriately substituted the limits that we've found here, and then with du being equal to cosine theta d theta, that has been substituted appropriately. So square root of 1 minus sin square theta is the same as square root of cosine theta, which is the same as cosine theta. So this cosine theta is cancelled. And so we are left with the integral from theta equals to arc cosine with the power -1 to theta being equal to pi over 2 of 1. And that results into, okay, obviously theta with the limits shown here. And so we have pi over 2 substituting plus of theta minus the lower limit arc cosine e to the power -1. And this is the answer. Very interesting. Thank you so much for following along. We appreciate your support. Until next time.